Welcome to another edition of an instructional video. Today we are going to consider finding the integral of cos cubed theta d theta. I'm going to do this, actually this is surprisingly simple to do. I'm going to take a couple looks at this problem. They're essentially the equivalent way, but maybe two different ways of looking at the same thing. And you can kind of pick which way you like to look at this. First of all, what I can do is I can say, all right, let's write cos cubed theta as cos theta times cos squared theta d theta. And then I will write this as the integral of cos theta times, using the trig identity that, of course, the sum of sine squared and cos squared has to be 1. So I can rewrite cos squared as 1 minus sine squared theta. Okay. Now, if you look at this, I can one way that I could do this is I can distribute this, and so I'm going to get, so let me kind of divvy up the page into two parts here. We're going to look at maybe an easier way of looking at it on the left, and then I'll show you an interesting way of looking at the same thing on the right, and you can pick which one you like. All right, so we have integral of cos theta d theta minus the integral of cos theta times sine squared theta d theta. And then what I can do is I can say simply, of course, the integral on the left is just going to be equal to sine theta. That's real simple. And then if I say let's do a u substitution. U, I'm going to let it be sine. And so if you take the du is going to be cos theta d theta. And so the integral on the right is going to be minus the integral. Now notice that I have a cos theta d theta, and that's exactly equal to du. Alright? And moreover, I can write this sine squared theta, I can write this as sine of theta squared. Okay? So I've got essentially, and of course sine theta is u, so I've got u squared times du. Okay, so that's pretty harmless. You can see that what the result is going to be very simply. It's going to be the integral of u squared du is minus u cubed over 3, right? Or a third of u cubed, plus we pick up a constant of integration. And then we sub in back for the u in terms of theta. So this is equal to, this is going to be sine of theta minus a third of u. U is sine of theta, so that's being cubed. So this is minus a third of sine cubed theta plus a constant of integration. Okay, so there you have a formula to express the integral of cos cubed theta d theta. Let me make a small diversion here on the right side of the page, and let me say a word there, and then we'll maybe repackage this result in some ways that you may find it in other resources and books, etc. But another way of looking at this is to come at this point, look at this. We have, if I were to write, so writing, instead of d theta, if I were to just write this as d sine of theta, check this out. Now, this is a differential of sine of theta, so that by the chain rule, okay, this is by the chain rule here, I have to take the derivative of sine of theta, that's cos of theta, and then I have to take the derivative of the argument of theta, that's d theta. All right, and that's exactly what we had over here, if you remember, when we called that du. So this integral here that we had, I can write it this way. Watch. I can write this, the cos theta d theta is my d sine of theta. Okay, so I can write this as the integral of d sine of theta. So the red underlined portions here, let me double underline it so you see it one more time. These are taken care of, this term right here. And what's left over? We have 1 minus sine squared theta. Okay? All right, so very good. So now check this out. So I get this is equal to, well, we're doing the integral with not theta, but with regard to sine of theta. So the integral of 1 is just going to be sine of theta minus the integral of sine squared theta of d sine theta is going to be a third of sine cubed theta. And then we're going to pick up a constant of integration. So we get the same exact result. It's just basically, like I said, it's two slightly nuanced ways of looking at the same thing. Okay. Now let me also repackage this result, which is exactly that result. Let's repackage that. So I'm going to say, or another way of writing this is to say the following. I could say, I've got a sine theta and I've got a sine cube theta. Let's pull out a sine theta in common there. Then I'm going to get 1 minus a third of sine squared theta plus that constant back here outside of the brackets there. And then remember that this sine squared is equal to 1 minus cos squared theta. So if I put that back in, I'm going to get the following. We get, this is equal to sine of theta times 1 minus a third of 1 minus cos squared theta plus the constant again outside of the brackets. And so this is sine of theta 1 minus, let's distribute, minus a third. Minus a third times minus cos squared is a plus a third of cos squared theta plus that constant. And this is equal to sine of theta. 1 minus a third is 2/3 plus a third of cos squared theta plus that constant out there. And now I've got a third in common, so I could write this as a third of sine of theta times 2 plus cos squared theta plus the constant outside. So let's summarize. Therefore, the integral of cos cubed theta d theta is equal to sine of theta minus a third of sine cubed theta plus a constant of integration. Well, that is also sometimes written in some textbooks as a third of sine of theta times the expression 2 plus cos squared theta plus a constant. Okay, so it's your pick, however you like to look at it. And there you have it, folks. We will see you in the next video, most likely, which is like this one. It's the integral of sine cubed.